speaker, Dr. Nirmal Gaur, CEO and Master Trainer at ThinkAI Cognitia, a machine learning community at Bhopal. Dr. Gaur holds a PhD in computer science and engineering from VIT Bhopal and brings over a decade of experience in teaching, research, and professional training. He has mentored faculty members, students, and industry professionals in advanced areas of artificial intelligence, machine learning, deep learning, and generative AI. Today, he will be sharing his valuable insight on the topic AI in healthcare, highlighting how intelligent systems are transforming medical diagnosis, treatment, and healthcare delivery. I now invite Dr. Nirbal Gaur sir to kindly take over the session. Sir, please.
Thank you, Nishtha, and good afternoon, everyone. Good afternoon, Madam Madhvi, ma'am. And I would like to thank you, ma'am. You have invited me for this talk in the FDP. So, as Nishtha told that I will be speaking on AI in healthcare. Let me share my screen. I hope my screen is visible to everyone, and you can see a white template. Is it visible?
Ye- yes.
All right, thank you, thank you. So I will be discussing from basic of AI in healthcare, especially about medical imaging. Well, I hope most of you people are working or worked on medical imaging, data analysis, algorithm, or model development in your research. In medical imaging, we do have data in form of images, and these images are of internal organs of our body, which tells where exactly an issue is. So if we talk about AI in healthcare, which is one of the important or core areas or application of artificial intelligence. Artificial intelligence, we want to make a mimic of humans. That means we want to transfer same kind of knowledge, ability in machines where they can think, and they can perform the task in a similar way. If they can do, we want to automate the problems related to healthcare. Like currently radiologists are working, and whatever be the medical images are being taken in form of x-ray, in form of ct scan, in form of ultrasound, etc., there are so many forms. Okay, so like currently radiologists, they understand those images, they annotate those images, they write, they make the reports for those images, and doctor take a concern for it. Well, in AI in healthcare and medical imaging, we wanted to build models, techniques which can interpret these medical images. Okay, and I hope you are well aware of the problem statements like brain tumor detection, breast cancer detection, chest x-ray, pneumonia, COVID, tuberculosis detection. There could be liver tumor, kidney. Okay, there are so many applications. If I write here, now it will be a huge list. Okay, as I said about images and mentioned, there could be X-ray, there could be CT scan, there could be ultrasound, mammograms, PET, different images are there. Either it could be grayscale or color images. Grayscale images or color images. Grayscale images are images which are one channel. They do have pixel intensity from 0 to 255. While color images are RGB, three channel, and every channel do have a pixel intensity from 0 to 255. Okay, let me draw it like in this way. This is RGB. Okay, and every channel to have 0 to 255 pixel intensity. And if you want to mark a pixel, it can be like this. And let me represent by a coordinate 110 comma 125 comma 254. This could be a color which is made up of RGB. Okay. In medical imaging, usually we have seen the images taken are grayscale images because only one channel is there to perform the task. If we take color images, then we have more information present in it because of the three channels, three colors. But grayscale images, as like X-ray, are also grayscale. CT scan, like also grayscale, might be color, but grayscale. Let's consider ultrasound images, mammograms. All these are the grayscale images. Okay, so we prefer this format. Okay. Apart from that, medical images can be present in file format like DICOM, like NII, neuroimaging, or digital imaging, where these are metadata. In this, we do have images along with the patient details present in it. Okay. So we needed to extract the images from file format as mentioned by using some Python libraries, and then rest of the task will be done based on it. All right. If you are available with the images directly in your data, then it's good. That means there are specific folders. For example, you are working on brain tumor and you are available with the folder of tumor, you are available with the folder of no tumor, and images are present in it specifically for tumor and no tumor. It's easy to work. However, if you are having a metadata, then you need to do some extra exercise. You need to identify where actually the file is present, and then you need to capture all those files, prepare your data, organize your data, and then rest of the algorithms, rest of the steps or techniques you need to follow up. Okay, got it. Then comes, sir, okay, we are having medical data, we are having medical images, then what to do? See, I'm not here to talk that I do have any presentation. I will show you that these are the points and take care of these points. No, no, not at all. I don't talk like that. I start from scratch and I will demonstrate a project also in front of you. Okay. So, like, and research perspective, especially. So, I identified my problem that in healthcare, I want to use AI. I want to build some algorithm. I need to build some technique which I will be applying. Okay. My problem statement is brain tumor, let's say. Okay. Then What to do, what algorithms we do have. In artificial intelligence, like it's a big domain, we have ML, machine learning, Machine learning. What we do in machine learning, sir? Machine learning, sir, we build models. Models are much more statistical in nature in ML. We call them as statistical models. We feed data into these models and perform training. Then we expect predictions from these models. Okay. Statistical means based upon the distribution of data. However, ML models are not that much capable enough if the size of the data increases, and if you are having a complex data, as you are talking about currently, image especially. I'm much more concerned about the images. You may have a data set, you deal with the data set in medical, like CSV file or Excel file, there could be such kind of records. Okay. However, I deal with this image part, which is much more challenging. So, if the data size increases, capturing the data patterns is not been sufficient for ML algorithms. Like if you take logistic regression, decision tree, random forest, etc., etc. Then we need to think deep. We need to build an algorithm which will take care of deep patterns recognition in the data. So then comes the deep learning part, DL. And in the deep learning, we build architectures. Okay. Where you do have neural network, where neurons are present over the layers. So you build architectures. Okay, fine. There is a neural training. Okay, there is a neural training. All right. What we know, or we have used, or we have seen, or we have made the papers based upon image processing. We are aware of CNN, convolution neural network. Sir, this thing na is being used a lot, sir. Convolution neural network. That means you are having convolution operation, convolution layer along with neural network. Neural network. What is this convolution? Convolution is a operation, and it's a feature extraction technique. It behaves as a filter. So we do have an image, we pass it to convolution for feature extraction, because not everything present in the image is important. No. Why to train your model with entire image? Why you are wasting the resources? No, no, we are not going to do that. First, filter the image, reduce the image, identify those features which are important. Then, whatever left with you, which are relevant details, important details, kindly train the model with that. So, we apply convolution over image. Okay, convolution, as I said, it's a filter. So, image is represented by a matrix. That's the easiest way. If we want to get better in AI, obviously linear algebra part should have to be important. Without a linear algebra, nothing is possible, because representation of data is being done with the help of linear algebra. You should have a knowledge of matrices and the vectors. Okay. So I represent here image with a matrix where pixel intensities from 0 to 255 are present. Then I will be applying a filter or a convolution, let's say of size 3 cross 3. That's more preferred. We can have 5 cross 5, we can have 7 cross 7, we can have 9 cross 9, which can capture more spatial dimension from the images. But like for complexity and computations, mathematical operations, we are not preferring that. So let's consider 3 cross 3 as the best option. So this matrix, which is a filter matrix, that will multiply each and every element present in the image matrix. Okay, I'll show you that diagram also. You are also very aware of that. There is pointwise multiplication. Okay, fine. And here, then here, like that. And result will be a feature map. We call this as a feature map, which is reduced size than that of the original image. This is feature map. Okay, we continue the process of convolution. Along with, we do have pooling layers also, which we apply along with the convolution. Pooling is a dimensionality reduction technique, and we have different kind of pooling, different types of poolings, like min pooling, max pooling, average pooling, global average pooling. Okay, let's say this is your feature map which you have achieved after convolution. 10, 12, 5, 4. This is what you got after applying convolution. So if I pass this thing to 2 cross 2 max pooling, I will be getting, okay, which value is maximum in this 2 cross 2, sir? Maximum is 12. So you will be getting 12 as an answer. That means I am going to fetch the maximum information which is present in the feature map. This is what I'm going to take. Similarly, here also, let's say this is 14, I'm going to get the 14. Let's say here it is 8 maximum, so I'm going to take 8, and here it is 16, I'm going to take 16 here. This is max pooling. Okay. So the research is like how you organize layers. We make research papers, we make architectures. In the architecture, your concern is we need to make a hybrid architecture. Let's say, sir, hybrid architecture we want to make, in which we will take this model, we'll take that model, and we'll combine the model, and like this is how we are going to organize the layers, and this will be the feature extraction, and finally after training of that much epos, and these results are coming to us. Okay, that's what we do, and we build a paper. That means organization of layers, how you do the setup. Or are you interested in making custom layer, custom mats? If you understand that there is a problem here in getting much more relevant feature, getting much more informative details, we are not achieving that in the existing architecture. You read in some research paper, you identified the problem, you try to improve it. So custom layers are required, like attention layers, attention layers. Okay, fine. So in a general, the flow is like, you do have an image, you pass it to convolution pooling, convolution pooling, convolution pooling. This is how you follow. And once you have extracted enough features or relevant features, like depending upon the size and shape of the image, because if you start with, let's say, 224 as the size of the image, shape of the image, okay, and like you are ending with 7 cross 7, 1024, the size of the image is now reduced to 7 cross 7. Remember one thing: whenever an image is passed through convolutions in a sequence or a series, definitely the size of the image is going to reduce. We're not going to end up. The At most we can go till 7 cross 7. Okay, we're not going to end it entire completely, no. So size of the image reduces, number of channels increases. All right, got it. Let me clear you this fact. Let me clear you. Let's say you are having an image of 224 cross 3 channel image. You pass it to a convolution of 32 filter. Okay, 32 filter. So what will happen? What will happen? 32 filter means 32 kernels. This is filter number 1 or kernel number 1, filter number 2, filter number 3, filter number 4. Up to 32 filters are there. All are in parallel. All are in parallel. Okay, and convolution, I said that is filter of size 3 cross 3, 32 are there. So every filter is of 3 cross 3, and do they have some values present in it which we call as parameters. So convolution do also have a parameter. Okay, so this image will be operated by this filter, this filter, and all these 32 filters. I am going to get a feature map 1, feature map 2, feature map 3, feature map 32. Okay, so 32 feature maps I am going to get. This is called as depth. Ultimately, that will behave as a channel. Okay, channel. Fine. So initially my image is of 3 channel. After passing through a convolution of 32 filter, my image will be converted into 32 channel, and its shape will be reduced like the formula for calculating the new shape is given by image height minus kernel height plus 2 into padding bits divided by striding. That means movement of a filter over an image, that is called as striding. Okay, plus 1. Okay, this is the height of a resultant image. Similarly, I can have image width minus kernel width plus 2 into padding divided by striding plus 1. This will be the shape of the resultant.
155,
Okay, fine. So let's say we do have
2155.
222, 222, 32. This is what we are going to get. This is the result which you are achieving after passing one convolution. And then if you pass it to another convolution, 64 filter, again the number of channel gets to 64. And the size again will reduce. So channels increases, size decreases of the image. And after getting all these stuff from the convolutions, you got the relevant features. Let's say 7 cross 7 1024, pass it to flatten layer to convert this into 1D, one dimension. That's a flatten layer that converts this thing into one dimension as an input. After that, you need to apply neural network, give these features. This will be as an input x1 x2 x3 dot up to जो भी result आ रहा whatever. Now you have to give this thing to the neural network. Now neural training will start. Okay, fine. Got it. And your task could be, sir, we want to do classification. Sir, we want to do segmentation, classification or segmentation. Whatever you want to do, you can. Classification, okay, categorize. Categorize. So categorization can be binary or multi. If you are having two classes, then it's binary classification. It's more than two classes, then it's a multi classification problem. Segmentation is to divide an image into segments. What exactly it means? It means that you need to classify pixels. I'm not talking about the entire image. I'm talking about pixels. So if you do have an image, let's say this is the brain, skull, and here is a tumor region present. So I need to identify those pixels which are making up the tumor. So segmentation is to classify pixels based upon the region, based upon the area. This is tumor region, so pixels of tumor will be different. Rest will be clear. Okay, fine. So like in segmentation, we do have image with its mask. I hope you have already worked on such problem statements for segmentation. Image will be, let's say, for a tumor image, a grayscale image, and its mask will be an annotation file. A annotated file. Annotated file means where an expert has already built a region where actually tumor is present. Okay, like this. So the region where tumor is present, that will be white pixels, all white pixels. I call it as foreground, and rest will be all dark background. Foreground and the background. Okay, this is how you will be getting in combination image with its mask. Foreground, background will be present in the mask, representing where actually which region. Because if this is a tumor image, that is fine. In classification, we got it. But where actually the tumor is present, we need to identify the region. So kindly mark it. So the training will be done according to such a data set. This is foreground and rest will be background. Okay. Noted. Therefore, we make algorithms or techniques for classification, for segmentation. There are other tasks also. Segmentation, well, in segmentation, in general, we do have two types of segmentation: semantic segmentation and instance segmentation. There are others also, fine, but we focus in general these two types of segmentation: semantic and instance segmentation. In semantic segmentation, as I explained above, that if you do have, let's say, apples present in an image, you need to do the segmentation, or you need to identify the pixels which are making the apples. Okay, so these are the apples which are marked in the segmentation. Pixels will be identified, but it will not let you know that there are three apples. Okay, there are three apples. There are in number 1, 2, and 3, but in semantic, it will not let you know. It will not further classify that these are three. Apple means apple. However, in instance segmentation, we do have instance means object. Okay, so we do have the segmentation as in semantic. Along with that, we also let let to know that there are three apples: one, two, and three. So that's instance segmentation. Okay, semantic plus further object which is present in it, that is classified. That's instance segmentation. Okay, classification, as usual, I told you, binary or multi, and segmentation in semantic or instance segmentation. Fine. In classification, the algorithms which we build, like CNN, convolution neural network, which is much more famous, which became famous after 2010 till 2015. Convolutions were used, still also convolutions were used. Okay, but after 2015, what happened was we do got pre-trained models. pre-trained models. This is what we get, because the researchers, scientists told that we are available with the data, benchmark data, ImageNet. They told we are available with benchmark data, which is having millions of images, thousands of categories. Now you bring algorithm from your side, and let's have a challenge. Let's have a competition. You bring your algorithm. We are available with the data set, and let's test that whose algorithm is going to perform better classification. Therefore, by this challenge in 2015, so many algorithms came, like like VGG16, VGG19, Inception, Exception, ResNet, EfficientNet, DenseNet, MobileNet. All these algorithms came, and they are trained on ImageNet dataset. Okay, ImageNet dataset. They all show good results, but different architectures. So if I talk about the time period of 2015 to 2020, most of the research papers were published based upon these pre-trained models. I hope you also did. Okay. Image classification using pre-trained model. And the technique applied was transfer learning. Transfer learning. Okay. So if I pick up one algorithm, let's say I picked VGG, Visual Geometry Group, 16. That means it is having 13 convolution layers and 3 dense layers. It's a sequential architecture. We do have convolution blocks here. We do have convolution blocks here. In a particular convolution block, we are having convolution pooling layer. And if I exactly talk about the architectures, we do have activation function also, let's say ReLU. We do have the batch normalization layer also to normalize the data, to standardize the data, so that the pixel value should be coming under some fixed range. That's very much important for neural training. Okay, so these layers are also being present. Let's talk about the main convolution layer, pooling layer. This is one of the convolution block. Then we do have further convolution block, further convolution block, further convolution block. So 13 all total convolutions are there. Then at the end we are going to extend, we are going to put the dense layers. 3 dense layers are there. 3 neural layers are there. That will make the entire VGG16. And this architecture is trained on ImageNet dataset, as I told you. And it proved to be giving some good score. At that time only, in image classification task, we reached till 90% accuracy. 90. Then later on, the architectures came 95% and 96% and 97%. Now, what's there in research? You already got 98 and 99%, 99 point some percent or so percentage of accuracy. What's left in the research? Well, according to me, there are two things if I focus upon the research. One is, of course, you are going to build something. You are going to develop some model. Okay, let's say you are going to build some model. Okay, what model comprises of? That's what I'm teaching you here. That's what I'm telling you here. Model have two components. That's pretty much clear. One is your layers of convolution. Let's say that means the technique which you have built for feature extraction. And else side you are having neural network. So model have these two components. We people mostly work here in this side. I told in the starting, sir, we need to make a hybrid architecture. We need to introduce this layer in our architecture. We need to build that layer. So we usually work in this side, but we skip this part. That is there any scope? Can we change the neurons? Is there anything? But don't skip this part. Here also research is available and it's coming. Quantum computing, physics informed neural network, PIN. Okay, quantum is also there. Quantum is also coming. There is a scope here also. So at both the ends, we do have the scope. Got it. Fine. So I was telling about this VGG model. It's a sequential model having convolution blocks present, convolution layers present in it, trained over ImageNet data set, proving to be good score, having the good score. Okay. Then advancement, let's say not advancement, another architecture with VGG 19 came, organizing the layers furthermore. Three more layers have been organized ahead. Okay. This also proved to be good architecture, pre-trained model. But as I already raised an issue, that we cannot keep the layers in a sequence for long time. No, it will end up the image. End of image. If you keep on putting convolution, 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 it will end the image. So sir 19 तक तो ठीक है 19 तक we did. अब what's next? हम और क्या architecture बनाएंगे? Then came as inception. Then came as inception. They told एक what they do is एक काम करते हैं सर parallel arrange करते हैं. Let's arrange the layers in parallel. And you apply some more concepts to it. What we can do is, sir, let's say here this is one of the layer. Once we proceed ahead, we do like this. This is arrangement of layers. Okay, like this. Later on, whatever we are getting, concatenation. So if this is the base layer, let's say this is the base layer. We do have the intermediate layers ahead, like and they are parallel in nature. Okay, there is a factorization. Factorization means now I'm not taking 3 cross 3. Inception told that you can take 3 cross 1, 1 cross 3. Factorization is also there. So whatever be the features you are extracting, you can concat ahead later on. And with the help of this or such proposals, such architectures, we are able to increase the length of the architectures or the models till we reach to 40 also, 40, 40 plus. We can organize the layer till 40 or 40 plus. So we do have Inception V1, Inception V2, Inception V3, Inception V4 models. Till Inception V3, V3 it's integrated in our Torch or TensorFlow, these frameworks for deep learning.
रिकॉर्डिंग स्टार्ट कर दी थी मैम
V4, we have to build from like our side from scratch. Okay, but it's there. That its code is also there V4, but we need to. It's not integrated, I guess. Still, the things like went on research, and the architecture came, which proved to be one of inspiration. ResNet, ResNet architecture, residual network. This came. What happened in residual architectures? In residual architectures, they told us that there is still a problem in the previous architecture that the flow of information is not proper. The flow of information is not proper. Okay, calculation of gradients is not good. We are facing a trouble. Vanishing gradient, or exploding gradient. These are the issues in neural network. And like capturing the features, and if anything left, then how you are going to recover it ahead. Therefore, ResNet architecture, they told that let's say this is your convolution block. This is your input X. Okay, this is your convolution block. And this is your output Y. Okay, what we are going to do is in the residual architectures, we are going to have a skip connection. We are going to have a skip connection which will tap the input again with output, and the answer will be x plus y. Let's say this is a function f of x. This is a function f of x, or it's a convolution block. So features are extracted from x. The output is y, and we are again going to back add it with y. Okay, retaining the information, retain, and add into the extracted features, and continue the process. Okay, so x, this is one of the block, this is another block, this is another block, this is another block, skip connection, skip connection, skip connection, skip connection. This is the final output. And since we are conveying the information ahead, we are not going to end the features quickly, no. You're carry forwarding na, information. So how you are going to end up? By this way, we have further extended the architectures. ResNet 101, ResNet 50, 52 also. There are versions of ResNet. ResNet 101, ResNet 152. That means 152 layers extended. This much layers we are having. Previously, we were struggling. Only 16 layer, 19 layer. Now we are having 100 plus, 150 plus layers present. Why? Because of this skip connection, residual connections, and very, very important. This concept is very much important. Okay. However, still the issues are there. Our expectation never goes down. We have more expectations. By seeing the success of ResNet, DenseNet architecture came. DenseNet architecture came. DenseNet told that don't only copy, that means carry forward the existing. You do one thing: prepare an architecture which can share share the outputs to the next layers also. So we should be having deep training. All right, so whatever I'm getting from this convolution block cb1, I'm not only sharing it to this. No, cb2, cb3, cb4, cb5. No, not only to this. I will share the results to this one also. I will share the results to this one also. I will share the results to this one also. Every convolution block I will share. And whatever I am going to get from here now, here I am sharing. This also. This also. From here I am getting. This also. This is DenseNet architecture. We are having deep training now. Deep training or deep learning. Deep feature extraction. So DenseNet again, DenseNet 201, 200 plus now. Okay, we further now scaling the architectures to 200 plus layers. DenseNet 169, we have a versions of DenseNet. Okay. This is what we are doing. Again, one of the good model, but like complexity increased. Because of the increase in the complexity, further more architectures came. But let it be. I'm talking about the pre-trained models. I'm talking about the era of 2015 to 2020. This era, where so many research papers were published by taking these models and taking our own data. We are having exception model where depth-wise separable convolution was used, DSC, depth-wise separable. Because of the complexity, seeing the complexity in the model, all computations. It happened to be like the authors proposed, if you are having an image, then then you have to you have to train or apply the filter depth wise. For example, if this is the image 224 comma 224 comma 3, so I am having three channel. Okay, so apply filter as depth wise or the channel wise. So this is three channel image. I will apply filter here, I will apply filter here, I will apply filter here. Depth-wise convolution or applying depth-wise filters. I'm going to get the result from here, feature map 1, feature map 2, feature map 3. Later on, I'm going to concat. Rather than taking an image all together and applying the filters, that is a very hectic process. Lot of computational complexities there, lot of multiplications are there. The authors came up with an idea that we can apply depth-wise filters, point-wise filters. This is what we can do and reduce the computational complexity. So obviously, research, as I told at one end, you do have a model development. Second is the computational complexity. Computational complexity. Complexity. So we have to develop some maths. We have to develop some logic, which can reduce the computational resource requirement. This is what we want. I need less memory. I need I need less CPU or GPU utilization for my model, my algorithm to run. If I can do that, I'm done with my research, my part. And obviously, score should be high. Someone achieved the score of 98. If I can make it at to 98.2 on low resources, I won the game. Or the same data, over the same data set, I'll win the race. This is what we need to do. Exception, then mobile net architecture, mobile net v1, v2, v3. That means any architecture, any model which can be used on edge devices. Right now, research is going on this field. Also, might be you guys are working. Some of them are working on edge devices, where we want to build an algorithm for a detection. Okay, so mobile net came, and mobile net architecture uses inverted bottleneck. Inverted bottleneck. This is what it use for residual connection. Residual connection. It uses inverted bottleneck for residual connection. Okay. In general, we do have a deep, narrow, deep like this for residual connection. It uses inverted. Narrow, deep, narrow. Organization of layers. So MobileNet is a lightweight architecture with same capability to perform the detection or classification, trained on ImageNet. All these models are ImageNet trained. Okay, just how to organize the layers, how to fix the problem, and reduce the computational complexity. That's the game. We do have efficient net also, efficient net model, starting from B0 to B7. These are the variants of efficient net. This is lightweight and this is heavyweight model B7. And in efficient net, we have compound scaling.
उसके बाद मीटिंग हुई होगी ना आज, मीटिंग
Okay,
हुई ना, क्या क्या किया उस काम मामले काम को लेके।
okay. We do have compound scaling. And in compound scaling, because what's present in an image? We do have the resolution. We do have a resolution, image resolution, height and the width. We do have the channels. We do have the channels. Okay, depth of layer. All these things we are having as a parameter. So in efficient net, they told let's make an architecture which can take care of all these things, channels also, resolution also, length of the depth or length of the model, how much it should be. So it's compound scaling. That means if resolution is more, how much is going to impact the channels, how much is going to impact the depth of the layers or length of the model, how it's going to impact. There's a formula they come up with: alpha, beta, gamma nearly equal to 2. Okay, in multiplication with these. So if you want to scale these layers or channels or resolution, so something like this formula came. That's compound scaling. Good model, good architecture, efficient net also. So from 2015 to 2020, we use all these architectures. That's an era of transfer learning. Era of transfer learning. So many research papers were published. Right now, also, if you are working on images, might be. Is there anyone who is working on images? Please let me know who published such papers or likely to publish the papers based upon transfer learning. Yes. Anything, please. You can unmute yourself and ask, say, please, where you have worked. Anyone? All right. So, like in transfer learning, as I told, we are going to use these models and trained on imaginary data. That's what also I told. We'll take these models, pre-trained models, and transfer their knowledge by adding upcoming layers. We add some layers. We add some layers in front of these models. Okay, pre-trained model. We do have all these pre-trained models. It's as per your choice of interest, and we add few more layers ahead of it. We transfer the knowledge or the weights or the parameter values to these layers. These layers are dense layers. Dense layer 1, dense layer 2. Let's say this is global average pooling layer. We transfer the knowledge. And we provide our data. Let's say brain tumor data. We provide our data and tune the neurons which are present on these layers. We don't touch the pre-trained model. We freeze it. We freeze it and don't touch the pre-trained model. Only we need to train or we need to adjust the weights, the parameters of this pre-trained model which is transferred to these layers. This is what we call as transfer learning. So people get confused. People get confused. What is transfer learning and what is fine tuning? Transfer learning and fine tuning, what it is? As I said, in transfer learning we do share the knowledge to the upcoming layers, and by our data we train, and training is done here only, not here. But in fine tuning of a model, let's say I told now VGG16. So let's say this is VGG16 model. Let's say this is VGG16 pre-trained model. Got it? We are not going to add few layers ahead of it. No, 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 no. What we'll do is we will unfreeze. Let's say we are going to unfreeze two outer layers of VGG16. We are going to unfreeze two outer layers of VGG16. Rest we are not touching. And now we are going to provide our data to train these layers only. These only. This is called as fine tuning. Fine tuning means we are just want to make our model aware with the new data. My model already knows about ImageNet, huge data set. It's already having a knowledge of ImageNet. Now, what I'm expecting is we want to fine tune you, we want to give you an awareness related to our data set. So, kindly adjust according to it. Okay. So, this is transfer learning and this is fine tuning. Okay. Got it. So these models were mostly used for transfer learning, and the papers like brain tumor classification, breast cancer classification, this and that, all classifications went well till 2020. Then what happened during that time, 2020, LLMs came, large language models were already present. 2021 something, that time, 2021 times chat gpt came. Okay, chat gpt. So so the chat gpt was made on transformer architecture. Transformer. And with the advent of chat gpt, it's a very successful architecture. We already seen how the results are coming for the chat gpt, from the chat gpt. In transformer we do have two components: encoder and decoder. Two components are there in the transformer. Encoder, obviously, to encode, to represent the data in some notations. It's a representation. That's encoder. Decoder is used to generate. Decoder is used to generate. So in a transformer we do have encoder and decoder. Encoder is to convert data into some representation, and this representation again I'm going to generate into a data that is called as data generation. So if you've been asked like who is giving you all the outputs, will chat gpt and all these LLM tools? Decoder, remember, gpt is decoder only architecture. All right, fine. So if you need to generate the data, if you need to generate the data, architectures proposed are something like this. You have an image neural network with 500 and let's say 1024 neurons, then 512 neurons, then 256 neurons, then 128 neurons, then 64 neurons. This is encoder or compression, data compression. I compress the data into 64 neuron. Here in this layer I compress the data. Then this is encoder part, this is compression part. Then I am going to put the decoder and reverting the process. After 64, 128, 256, 512, 1024. This is decoder part. Decoder, that means expansion. And here, if this is the image I gave, This is the image I'm going to get, I dash. And such kind of architecture are seen. Image generation, obviously I'm doing. In segmentation also we are having an architecture called as unit, you know about it, for generating mask. So if you want to generate something in AI, the successful architecture is transformer based, encoder decoder based architecture. Okay, got it. So transformer came after 2020. There's a paper related to vision transformer. Authors thought that if this is successful on text, why shouldn't we apply on images? So authors came up with VIT, vision transformer. Vision transformer. And what happened in vision transformer? Authors propose just same procedure as we do on the text. What we do on text? What we do on text? In a text, if you talk about the transformer, for example, my name is Nirmal. We perform tokenization. My name is, four tokens are there. Four tokens are there. We assign ID to each and every token. One, two, three, four. Positional ID. We convert these into vectors. V1, V2, V3, V4. These are called as embeddings. These are embeddings. And then we give these embeddings to the encoder. To the encoder. And in encoder, we do have MHA, multi-head attention mechanism. There's a very famous paper. I think everyone should know about this paper. In 2017, it was released. Attention is all you need. Attention is all you need. Because of this paper only, na, like BERT model, all these you are seeing LLM tools. Because of this paper only, attention is all you need. All right. So what happened that after doing the embedding part, converting every token into vector part, let's say let's say this is a vector v1 for a particular token. We divide it into three further metrics or vector q1, k1, v1. That is query, key, and a value. QKV, QKV, Q1, K1, V1, query, key, and value. For every token, we need to do the same thing. Q2, K2, query, key, and every vector, we need to do that. And let's say you are going to organize it in a tabular format. This is how you are going to organize. Okay. So if this is my query q1, okay, let's consider vector v1, v2, v3, v1, v2, v3, v4, v1, v2, v3, v4. If this is my q1 for v1 and a value for v1, this is q2, v2, q3, v3, and q4, v4. This is K1, K2, K3, K4. Keys. The formula proposed by the author in the paper, attention is all you need. They told that Q dot K ka transpose. That means take the dot product of query with the key of all other tokens. All other token keys, take the dot product. Q dot K ka transpose. So why K ka transpose? Why? Because query will be this vector key will be this vector. And you very well know how to matrix multiplication can be performed, and if they are in this way na, then only matrix multiplication will be performed. We need to take care of the size. So q dot k ka transpose, that's what they told. And after that they mentioned q dot k ka transpose square root of d. D is the length of the key. Length of key, this is called as d. Whatever be the length of the vector key, that's mentioned. So q dot k transpose square root of d in order to normalize this value. And everyone knows, like, I'm taking the dot product, and when we take the dot product, similarity. In order to find the similarity between the two vectors, then only I'm going to take the dot product. Okay, fine. So dividing by length of the key, applying softmax function. Whatever be the value you are getting here, apply softmax. Softmax is e key power x upon summation of e key power x. This is softmax. Okay, this is softmax. Once you are getting any the result from here, then multiply by the value v. This is what we call as attention score. This is attention score. So here the entire table will be filled with the attention scores. Q1 dot K2 transpose divided by length of the K2, taking short max of all these, multiplied by let's say V1. All these things we need to do. Fine. So scores will be mentioned here. And those scores are high. That means if a, let's say, this is high, this is high 0.9. So v1 and v3 attention is zero point 0.9. That means whenever v1 token is going to appear, v3 will attend it. That's why it's called as attention mechanism. If v1 will appear, then v3 should attend it. That's what attention mechanism is. Okay, got it. So same approach is applied in vision transformer. They copied the approach, but now taking the data in form of images rather than text. They told they told this is our image. Authors divide it into patches. Okay, there I was having a token. Now I do have the patch. Divide it into patch. So like this. Patches. Divide the image into patch. Like this. This is a patch. This is a patch. Patch. All these patches. Okay, fine. These are patches. Divided. So if you are having image 224 cross 224, you are going to divide it into patch. Each patch, let's say 16 cross 16. So you can divide 224 by 224, 16, 16. You will identify how many patches are there. How many patches should be there. So after dividing the image into patch, they organize it. Same as I told, positional. Because we are not going to, okay, we are not going to keep this patch after this, after, no. There's a proper order. So this is first patch, this is second patch, this is third patch, fourth patch, fifth patch, sixth patch, same like here only. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, got it. Patches. All arranged. Numbering done. ID given. Order given. Then converting into vector. Again, same thing. Embedding. Converting them into vectors. E3, E4, and so on. Convert them into vector. No, all maths is going on. This algorithm, vision transformer, converting them into vectors, also it's all maths going on. Okay. And once you convert it into vector, you very well know what to do next. MHA. You are going to pass these vectors into encoder block, where we are having the multi-head attention mechanism. So this is how it goes. Image, image to patch, patch to ID, embedding, embedding, then then giving it to the encoder. This is the encoder.
Scripted again. Ready side.
In encoder,
Normal గా
we do have
మీరు
MHA,
computer science program మొత్తం
multi-head attention. Multi-head attention, same thing which I taught. Q dot K transpose square root of this dot max, that one. Whatever be the result I'm going to get here,
let me complete
I
this
need to normalize it. Whatever I'm going to get it here, I'm going to normalize it. Normalization. So this thing will be given here as a input. Whatever you are getting as an output, let's say this is x, this is y, you are going to give it again here, concatenate, normalize. Then you need to give this thing to the feed forward network, that is neural network. And this is how you are going to get the result. Again, skip connection, residual connection. Here is the final output. This is the architecture of vision transformer. This is the architecture for vision transformer. And the difference between the CNN convolution and the vision transfer VITs. See, CNNs, feature extracting we are doing with VIT also by CNN also, but the approach is different. As you have seen, in VIT we are creating the vectors, and then we are applying attention mechanisms, and then we are performing the training. In CNN we are having the matrix representation of pixels, and then we do convolution or filter and keep on doing that. So the CNN is good in short range dependency. Short range dependency. If you want to extract a feature, short range, short. What do you mean by short range? I mean, in an image, if a pixel present here and a pixel present here, if I need to find the relationship between these two pixels, it's good. Okay, it's good. But if a pixel present here and a pixel present here, if I need to find a dependency between them or relationship between them, the CNN is not better. Then VIT is better. So for long range dependencies, vision transformer are used. Okay, fine. And like nowadays, we have switched to the architectures. VIT is also now we are having versions Swin VIT, Swin transformer, Max transformer. We are having upgraded versions for that. Okay, now we are having hybrid models also, which can integrate CNN and VIT both. Short range dependencies and the long range dependencies, both. We are having hybrid model. That's why in the opening I said what kind of architecture you are going to make. We are having hybrid also architectures. Okay, so this is vision transformer. All right, I do have all the notes, everything, all materials, but I decided to like deliver it from my end. Okay, now do you have any questions related to it, what I just discussed? Anything you want to ask? Let's have a two-way communication. Then I will demonstrate the code, the implementation. Anything you want to say or ask, please. Any question, any query, anything you want to put up, please. Yes, yes. Anything you want to say or ask?
Participants can unmute themselves to ask the queries, if any.
You can ask. Yes. Anything you want to discuss from your side? We are open for the discussion. Well, how you code, like, you do also work on the data sets, no? You work on the data set. You also build the models, algorithms, and how you take this thing AI in healthcare. Because I just focus more on research, like algorithm development. I talk about classification. I talk about the segmentation. These models which has been used. Okay, what's your perspective? Yes, you can tell. What do you think? Any research paper related to the medical imaging or healthcare part you have published? So you can tell. You can discuss. Well, for implementation, if I tell from my end, I use Kaggle. That is a data science community, Kaggle. Okay, I will show you my account also. Okay, and it has so many data sets available, open source, from where you can get medical data, healthcare. Apart from that, there are other data sets too present over the Kaggle. If you want to see, here it is. This is my Kaggle account. Okay, this is my Kaggle account. Fine. And why I use Kaggle might be you are comfortable, depend upon your interest. Google Colab also there is, where you can work, or any other platforms for Python, because Python programming has been required here. Or might be you suggest to the scholars or something like that, kindly, this is the data, this is the algorithm, this is the research paper in the algorithm research paper, and you please read out this and kindly work on such and such, so and so. Okay, they need to develop, they need to build the algorithms techniques. So what's the better fit, the best fit? The best fit is, I suggest from my side, you should have a Kaggle account. Here is the Kaggle account. Okay, and it's easy. You can set up your Kaggle account, register on the Kaggle. Okay, and do register with your mobile number, because the requirement here is now GPUs. Okay, GPU. If in your college GPUs are there, that's fine. You work upon. Else, a good thing in the Kaggle is you are going to get the free GPU for a week, and that is 30 hours. There's a 30-hour quota for the GPU in a week. If you do some training or what, 30 hours are, I guess it's enough in order to work. So free GPU for a week, in a week, 30 hours. There's a reset on every Saturday. Okay, so prepare or make Kaggle account. Data sets are already there. Okay, register via mobile number, you will get the free GPU also. Okay, rather than using Collab or all, in Collab you need to upload your data on the drive and other things. Here it's not required that. You can upload the data also. You can upload the notebooks also. Everything has been there. All flexibility is present. Okay, got it. So let me show you one project. That's what I did. And this project is brain tumor classification. And I worked on a data set, that is brisk data set. Let me show you this data set also. Brain tumor MRI data set for segmentation and classification. That's a benchmark data set. Okay, here is the data set. It's a benchmark data set. You can see the images. We do have both classification and segmentation images available in this data set. Classification, test, and the training. If you click on training, we are having four folders present here with category glioma, meningioma, no tumor, pituitary. Okay, okay, let's say I clicked on glioma. So these are glioma images. Okay, these are glioma images. Fine. Similarly, Similarly, there are images available in meningioma, no tumor, and pituitary also. Same kind of images. That's obviously grayscale images are present. Segmentation data is also available where images along with a mask is present. So if I click on the images, you can see these are the images, and we do have mask also for them. So every image will be having a mask. You are well aware of this. I explained in segmentation. We need to divide an image into segments, and you can see in this image we are having two grounds, that is foreground the white pixels and background is a dark pixels. The intensity, let's say 0 is for black and 255 is for white. So these are annotations for every image where the region actually tumor is present. So this is annotated by experts. And apart from that, there are annotation tools available by the help of which, if we are working on segmentation tasks, by the help of those tools, we can also annotate from our side. Got it. So I will be working here on the classification task at first. Okay, classification task. You have seen the data. You have seen the data. In classification, I am having four category. I am having four category. I am having all grayscale images present with me. I should have a knowledge about the images. You know what happened? There is a trouble between the guide and the trouble between the scholar, research scholar. What's the trouble? Trouble is guide से ये करके लिया ना वो करके लिया ना, scholar परेशान, क्या करके लिया ना, कैसे करके लिया ना. अच्छा, स्कॉलर्स के लिए ये प्रॉब्लम उसको समझ में आए. Unless and until we don't have the cut and clear knowledge about deep learning algorithms, तो वो क्या करके लाएगा. तो I'm talking as per how I deal all these challenges, okay, with many of the people. So we should have a knowledge of data first. Data, it's present ग्रे स्केल है, फोर कैटेगरी है. गोल आई नो कि आई नीड टू परफॉर्म द क्लासिफिकेशन. मल्टी क्लासिफिकेशन है, फोर कैटेगरी है, तो दैट्स व्हाट आई नीड टू डू. ठीक है. तो क्लासिफिकेशन के लिए ओके, व्हाट आर द ऑप्शंस अवेलेबल. either I can build the model from scratch, CNN based architecture I can build, I can use pre-trained architectures, मैं transformers वगैरह सब लगा दूंगा. और if anything proposed by the guide from any of the research paper कि ये भी try करो, देखो क्या हो रहा है, how results are coming, चलो ठीक है वो लगाएंगे. सो अब मेरी अप्रोच है ये, मैं आपको समझा रहा हूँ यहाँ पर क्या करता हूँ मैं, क्या बताता हूँ, व्हाट आई टेल, व्हाट आई टीच. डेटा है मेरे पास, देन टू बी वेरी बेसिक आई मेक अ डेटा फ्रेम. मैं डेटा फ्रेम बना लेता हूँ. आई प्रिपेयर अ डेटा फ्रेम मीन्स आई ऑर्गेनाइज द डेटा इन अ फॉर्म ऑफ इमेज, पाथ एंड अ लेबल. दिस इज व्हाट आई डू. मतलब ये रहा लोकेशन वेयर इमेजेस आर प्रेजेंट, और ये उसका लेबल है. पिट्यूटरी है, ग्लोमा और लाइक मेनिनगियोमा और नो ट्यूमर वॉट एवर. सो दिस इज अ वेरी बेसिक पाइथन कोड विच आई डू to create a data frame. This is my root path where actually the images are present. Rest I'm going to create a data frame. The two columns, one column is for image path, another is for the label. All right, fine. This is how I do. तो ये कोड कर लिया, डेटा फ्रेम बना लिया. ओके, ये बन गया, तो मेरा काम आसान हो गया. माई टास्क इज नॉट सिंपल. वंस आई क्रिएट अ डेटा फ्रेम, there are, if I check the shape of the data frame, I do have 5000 rows, 5000 entries, two columns. Obviously there are two columns, one is the image path, one is the label. There are two columns available with me and four labels are there. ठीक है, ठीक है. This is the information of the data frame. DF info, to be very very simple, that total 5000 entries are there in each column. Okay. The unique values for the labels, there are four categories I already shown you: pituitary, no tumor, meningioma, and glioma. There are four categories available. Now, what are the counts? What are the number of images in these categories? How many number of images are there? In pituitary, 1457. In meningioma, 1329. Glioma, 1147. And no tumor, 1067. So the number of images in these categories are different. चलो ये तो important बात पकड़ में आई है, very important, that the number of images in these category data are different. ठीक है, अलग अलग नंबर है, imbalance है ये. And let me tell you one of the challenge, ये biggest challenge है in medical imaging or healthcare or whatever. If you take a data में imbalance है, it's a challenge, it is a challenge. पहले तो डेटा मिलना, ये तो परेशान होगा स्टूडेंट. डेटा, फ्रॉम वेयर वी आर गोइंग टू गेट द डेटा, डेटा कहाँ से लाएं? इज देयर एनी रिसोर्स, इज देयर एनी रिपोजिटरी, इज देयर एनी ऑफिशियल वेबसाइट? क्या रिसर्च पेपर में लिंक मेंशन है? डेटा मिल जाएगा. अभी यहाँ कैगल पर डेटा वी आर अवेलेबल विद, ओपन सोर्स है वो, तो मिल रहा है. ठीक है, तो डेटा मिले पहले, नहीं तो फिर मेल करो ऑथर को, वो देगा, उसकी परमिशन लेना पड़ेगी. ठीक है, डेटा मिला, डेटा इम्बैलेंस मिला, होता ही है ना. वन कैटेगरी, लेट से नो ट्यूमर, इज नो ट्यूमर, thousands of images are there and only 200 images of tumor are there. अब मॉडल को कभी भी इम्बैलेंस डेटा पर तो मॉडल ट्रेन होता ही नहीं है, डेटा इम्बैलेंस है. एंड ऑब्वियसली हेल्थ केयर में चैलेंज है ये कॉन्फिडेंस डेटा. इफ इट्स टॉक ऑफ मेडिकल ना, मेडिकल का डेटा कॉन्फिडेंशियल होता है, ऐसे हर कोई नहीं अवेलेबल करवाएगा. ओके, सो वी रिकॉग्नाइज्ड हियर कि डेटा इम्बैलेंस है. ठीक है, कोई बात नहीं, करेंगे आगे काम. आई डिड सम विजुअलाइजेशन, थोड़ा सा विजुअल बनाया पाइथन पर, काउंट प्लॉट एंड पाई प्लॉट, पाई वगैरह कुछ, बार प्लॉट वगैरह ऐसा बनाया टू शो द डिस्ट्रीब्यूशन. नॉट वेरी हार्ड एंड फास्ट, कोई कोड मेरा हार्ड एंड फास्ट है नहीं, वन लाइनर्स. देयर आर फंक्शंस अवेलेबल, यू कैन पुट अप एंड यू कैन मेक द प्लॉट्स, नॉट एन इश्यू. ओके, तो काउंट प्लॉट एंड पाई प्लॉट एंड ऑल दीस थोड़ा सा बना लिया, पाई प्लॉट बना लिया. ओके, हियर यू कैन सी द डिस्ट्रीब्यूशन. एंड वी मीन टू पुट ऑल दीज ना इन अवर रिसर्च मेथोडोलॉजी. हम पुट अप करना चाहते हैं रिसर्च मेथोडोलॉजी में. देयर इज वन सेक्शन ना कि डेटा डिस्क्रिप्शन. In research methodology, we describe the data. So there will mention, ये plot लगा देंगे वहाँ पे कि that we have collected the data from this and this source. In our data set this much number of images are present, and for this category this much number of images, this category this much number of images, and see, check our pie plot, the distribution. अच्छा इमेज मिल गया डिस्ट्रीब्यूशन का. ठीक है, आगे बढ़ते हैं. फिर नेक्स्ट है मेरा कंसर्न, लेट मी डिस्प्ले 5 इमेजेस फ्रॉम ईच कैटेगरी, क्योंकि ये दिखाना पड़ेगा ना. वे भी डेटा था तो ये तो बता दो कैसी इमेजेस थी, शो तो करो हाउ द इमेजेस लुक लाइक. तो ठीक है, दिखा देते हैं आपको कैसी इमेजेस हैं. सो आई एम गोइंग टू डिस्प्ले 5 इमेजेस फ्रॉम ईच कैटेगरी. ये रही 5 images from each category. This is what I am going to display. तो ये इमेजेस भी उठा के मैं अपने रिसर्च पेपर में लगाऊंगा, दैट दिस इज हाउ द इमेज लुक्स. ओके फाइन, ये भी आ जाएगा डेटा सेट के अंदर. देन व्हाट हैपेंड नेक्स्ट? ओके, अभी आपने पूरा बेसिक एक्सप्लोरेशन करा, यू बिल्ड द बेसिक ईडीए. दिस इज कॉल्ड एज एक्सप्लोरेटरी डेटा एनालिसिस. यू डिड सम बेसिक ईडीए. तो स्टेप्स क्या होती हैं इमेज प्रोसेसिंग की? लेट मी टेल यू द स्टेप्स ऑफ इमेज प्रोसेसिंग. इमेज मतलब जब डील करना है आपको इस प्रकार के मतलब डेटा से. ओके, व्हाट आर द स्टेप्स? डेटा साइंस में, मशीन लर्निंग में, डीप लर्निंग, वॉट एवर, The step number one is data acquisition, data collection. Okay, collection. That's what we did from different sources. We collected the data from different sources. कर लिया. सेकेंड स्टेप होता है सेकेंड स्टेप होता है डेटा क्लीनिंग और प्री प्रोसेसिंग. डेटा क्लीनिंग और प्री प्रोसेसिंग. प्री प्रोसेसिंग. अब आप चाहे कुछ भी कर लो, वेदर यू आर हैविंग अ डेटा ऑफ टेक्स्ट, वेदर यू आर हैविंग अ डेटा ऑफ इमेजेस, कुछ भी है भाई, ये स्टेप जो है ना, ये तो मान के चलो ये आईएमपी है, इंपॉर्टेंट. इंपॉर्टेंट. अच्छा, आप भी फिर वाइवा में खींचोगे स्टूडेंट को, बताइए क्या क्या स्टेप लगाइए, आप लेकर आए हो अपना काम, बताओ जरा क्या करा है इसमें. व्हाट यू डिड इन योर रिसर्च, क्या प्री प्रोसेसिंग में क्या स्टेप लगाई तुमने. वो घबरा गया मान लो, अरे यार क्या पूछ रहे हैं, या कौन सी स्टेप बताएं इनको, कैसे बताएं. ठीक है, तो प्री प्रोसेसिंग. प्री प्रोसेसिंग, डेटा प्री प्रोसेसिंग. स्टेप नंबर वन देखिए क्या है. हम रीशेप कर लें अपनी इमेज को, रीशेप या रीसाइज कर लें. लेट्स से बिकॉज images can be of different resolution. Images can be of different resolutions. So we need to reshape or resize all the images in a specific resolution. Let's say 224 कर लिया मैंने. ये पहली स्टेप होगी. सेकेंड स्टेप ये होगी कि सर इमेज की क्वालिटी पुअर लग रही है मुझे, या तो मेंशन करो जो डेटा सोर्स है कलेक्ट करा, दे टोल्ड कि इमेज की क्वालिटी अच्छी है, चिंता मत करो, और यदि पुअर है तो उसको एनहांस करना है, एनहांसमेंट करना है. तो एनहांसमेंट के लिए कुछ टेक्निक्स है, जैसे आई एम राइटिंग CLHE, हिस्टोग्राम इक्वलाइजेशन टेक्निक, कॉन्ट्रास्ट लिमिटेड हिस्टोग्राम इक्वलाइजेशन टेक्निक. ये लगा सकते हैं जाके पिक्सल्स ठीक ठाक हो जाएं, स्पेशली दोज पिक्सल्स विच आर प्रेजेंट एट द बॉर्डर, वो सबसाइड हो जाते हैं, डाउन हो जाते हैं. ठीक है, तो उनको बेटर कर लेते हैं अपन. सो वी आर हैविंग अ टेक्निक. ऐसा कर लो, एनहांस कर लो पिक्सल की इंटेंसिटी को, तो इमेज अच्छी दिखेगी. ओके, इमेज विल लुक बेटर. आफ्टर दैट कर लिया सर, फिर नॉर्मलाइज करना है. नॉर्मलाइज द इमेज. नॉर्मलाइज दैट मीन्स पिक्सल्स जो हैं उनकी इंटेंसिटी को 0 से 1 के बीच में करना है. सम पिक्सल्स में बी लाइक its intensity will be 224, 224, some can be 254, some can be 10. तो नॉर्मलाइज करना पड़ता है, ये इंपॉर्टेंट स्टेप है डीप लर्निंग के अंदर. प्री प्रोसेसिंग जब कर रहे हो तो डेटा नॉर्मलाइज होगा. ओके, नॉर्मलाइज करा. फिर उसके बाद सर हमने कुछ ऑगमेंटेशन किया है. वी डिड ऑगमेंटेशंस. ऑगमेंटेशन, ऑगमेंटेशन, ऑगमेंटेशन. अच्छा, ये भी आपकी इच्छा है, आप कैसा करना चाह रहे हो. या तो आप डेटा को पहले डिवाइड कर लो. दैट मीन्स यू डिवाइड योर डेटा, यू डिवाइड और योर डेटा into training and the testing. You divide your data into training and the testing. Okay, and you apply augmentation on training and testing both. तो ट्रेनिंग में इफ यू अप्लाई द ऑगमेंटेशन, टेस्टिंग दोनों में लगाना है. ऑगमेंटेशन दैट मीन्स टू डू द चेंजेस इन द डेटा सेट, बिकॉज वी नेवर गिव डेटा जो कि इजी हो मॉडल को लर्न करने के लिए. नहीं, हम पैटर्न बदल के देते हैं. सो इन ऑगमेंटेशन वी कैन अप्लाई we can apply horizontal flip, vertical flip, rotation, brightness, contrast मैंने ऊपर लगाई दिया अभी. आप इमेज को जूम कर सकते हो. सो देर आर सर्टेन ऑगमेंटेशंस विच यू कैन अप्लाई ओवर द इमेज, ताकि उसको डाइवर्स करो थोड़ा सा. एज इट इज डेटा कभी मॉडल को नहीं पकड़ाते, इमेजेस में चेंज करो, जरा उसको डाइवर्स करो. ये सब लगाओ ऑगमेंटेशन. ओके, वी आर गोइंग टू अप्लाई द ऑगमेंटेशन और टेस्टिंग ऑल्सो. यहां भी लगाएंगे, डेटा को ऑगमेंट करेंगे. ठीक है, करा. डेटा में ये वेरिएशंस लेकर आ गए. सर एक चैलेंज तो था सर, डेटा इम्बैलेंस भी तो था. डेटा इम्बैलेंस भी है, तो डेटा को बैलेंस करो. डेटा बैलेंस करो. डेटा को बैलेंस करने के लिए देर आर सर्टेन टेक्निक्स, जैसे कि वन ऑफ द सिंपल टेक्निक मैं रीसैम्पलिंग. What I do in the resampling? Kindly create duplicates of minority class equal to the majority class. Minority को majority के लिए equal कर दो, उसके duplicate बना बना के, तो बराबर की बात हो जाएगी. रीसैम्पलिंग करो, ओवर सैम्पलिंग डुप्लीकेट करके नहीं, तो फिर एक काम करो, स्मोट, दैट इज वन ऑफ द टेक्निक, सिंथेटिक माइनॉरिटी ओवर सैम्पलिंग टेक्निक. सिंथेटिक इमेज बनाओ सर, फेक वाली, तो जाके बराबर कर दो, इक्वल कर दो. एंड आई होप यू आर अवेयर ऑफ जैन्स, जनरेटिव एडोजल नेटवर्क. ये भी कई रिसर्च पेपर कहने लगा रहे हैं, लोग लगाते हैं कि हम जनरेटिव एडोजल नेटवर्क यूज करेंगे फॉर क्रिएटिंग सिंथेटिक इमेजेस एंड देन वी आर गोइंग टू ऐड इट इनटू ओरिजिनल डेटा सेट. ये काम करेंगे, ठीक है, अच्छी बात है, करिए. क्योंकि वो ये ना शो करना है, अरे मेरे को मेरा रिसर्च पेपर पब्लिश करवाना है एससीआई में, जो भी स्कोपस वगैरह वट एवर यू टारगेटेड, तो उनको क्या चाहिए, अरे तुमने खिचड़ी बनाई हो. तो फिर सर हमने इतना करा था, फिर जैन का एक अलग आर्किटेक्चर हमने लगा दिया. दिस ऑल्सो हैव इनकॉर्पोरेट, हाइब्रिड है हमारा तो आर्किटेक्चर. वी यूज दिस, वी यूज दैट एंड वी मिक्स इट ऑल एंड दिस इज हाउ वी डिड द ट्रेनिंग. तो ये भी लगा दिया हमने, ठीक है, कोई बात नहीं, करिए. दिस इज व्हाट यू कैन अप्लाई, बैलेंसिंग द डेटा दीज algorithms करा. और जब ये हो गया, पूरा बैलेंस भी हो गया, नाउ ये पूरा प्री प्रोसेसिंग का पार्ट है. This is what the pre-processing part. And once you are done with this, now you can give the data into the model. Model में दोगे आप. Model, your designed model, custom model है, या आपका खुद का pre-trained model यूज कर रहे हो, क्या कर रहे हो, you have to give it to the model for training purpose. तो प्री प्रोसेसिंग बहुत बहुत इंपॉर्टेंट है. यदि आपने इमेज को फिक्स कर लिया तो आपका मॉडल बहुत अच्छा काम करे, मॉडल विल गिव यू बेटर रिजल्ट्स. और यदि यहां पर आप फेल हो गए, आपको नहीं समझ में आया डेटा कैसा था, ठीक है, और आइदर बाय दिस यू कैन फॉरवर्ड माय वर्ड्स टू द अदर स्टूडेंट्स लाइक हु आर वर्किंग इन दिस पर्टिकुलर फील्ड, इन दिस पर्टिकुलर एरिया. तो ये स्टेप बड़ी समझने वाली है, ठीक है. और यही आई डिड फॉलोड इन माई कोड ऑल्सो. यदि आप देखेंगे, अगला मैं पिकअप करा, I imported some libraries which are important for training and all required है मेरे लिए यहाँ. तो टॉर्च एक फ्रेमवर्क है इन डीप लर्निंग दैट आई यूज्ड फॉर दिस पर्टिकुलर ट्रेनिंग, ठीक है, मतलब इस कोड के लिए टॉर्च. देयर आर टू फ्रेमवर्क्स, वन इज द टेंसर फ्लो, अनदर इज द टॉर्च. टेंसर फ्लो गूगल का है, टॉर्च मेटा का है. ओके, टॉर्च मेरे को ठीक लगता है, दिस इज गुड फ्रेमवर्क. फ्रेमवर्क यानी कि जो कंप्यूटेशंस होते हैं ना, वो डीप लर्निंग, अभी आप जानते हैं कि क्या कंप्यूटेशंस हो रहे हैं. ये पैरामीटर एडजस्टमेंट होता है कंप्यूटेशन में, खास यही है. ये न्यूरॉन है, ये एक्स इनपुट है, ये वाई आउटपुट है, ये वेट है, ये बायस है. ये दोनों पैरामीटर है, वेट और बायस. तो वेट और बायस जो पैरामीटर अपडेट होते हैं ट्रेनिंग में, एंड हाउ दे आर अपडेटेड, डब्ल्यू डैश इज इक्वल टू डब्ल्यू माइनस अल्फा डेल एल बाय डेल डब्ल्यू. ये ग्रेडियंट कैलकुलेशन है, ये लर्निंग रेट है, ये ओरिजिनल वेट है, ये अपडेटेड वेट है. सेम सेम चीज बायस के लिए भी है, डेल एल बाय डेल बी. ओके, तो पैरामीटर्स अपडेट होते हैं ट्रेनिंग में, पूरा कंप्यूटर तो बैकएंड में होगा. और ये डेटा इमेज का है या टेक्स्ट का है, तो बड़ा डेटा है. ओके, तो टॉर्च जो है, टॉर्च ये फ्रेमवर्क है, ये सपोर्ट प्रोवाइड करेगा. दिस विल प्रोवाइड द सपोर्ट फॉर बैकएंड कैलकुलेशंस. ओके, और जरूरत पड़ने पर ये जीपीयू उठा लेगा, ग्राफिक प्रोसेसिंग यूनिट. और हमें तो जीपीयू चाहिए ना, आजकल जीपीयू के बिना काम कहाँ हो रहा है, सीपीयू का गेम ओवर है. कोई भी रिसर्च आप सक्सेसफुल होएगी नहीं आपकी बिना जीपीयू के. जीपीयू तो लगेंगे, ये तो मॉडल ट्रेन होगा. ऑलराइट, फाइन. सो लाइक हियर, अब हमने ये ले लिया, ये लाइब्रेरीज ले लिया, एंड देन आई डिवाइडेड माय डेटा इनटू ट्रेनिंग एंड वैलिडेशन और टेस्टिंग, वट एवर यू कैन अंडरस्टैंड, ठीक है, कर लिया डेटा को, फिर मैंने बैलेंस भी कर लिया. और एक बात ध्यान रखना आप, मैं आपको एक चीज़ और बता रहा हूँ, बड़ी इंपॉर्टेंट है. और मैंने वहाँ पर क्यों बोला कि पहले आप देखो, ये आपका डेटा है, डेटा. अब आपका डेटा इम्बैलेंस था, इम्बैलेंस था. Okay, data was imbalance. So don't balance it directly, मतलब by using some technique. Okay, don't balance the entire data by using some technique. ये नहीं करने का, ये रॉन्ग है. ये आपका डेटा है, उसको डिवाइड करिए पहले ट्रेनिंग में, टेस्टिंग में. और बैलेंसिंग सिर्फ ट्रेनिंग की होगी, टेस्टिंग को मत करना बैलेंस. ठीक है, बैलेंसिंग ट्रेनिंग की होगी. ओके, वाई, रीजन है. देखिए क्या है, इफ आई डायरेक्टली बैलेंस द डेटा, if I directly balance the data, and let's say I'm applying oversampling technique, which is creating the duplicates of existing, तो होगा ये कि मैं डेटा को बैलेंस आई डिड एंड देन आई डिवाइड फॉर ट्रेनिंग एंड द टेस्टिंग. तो होगा ये कि जो एलिमेंट्स ट्रेनिंग में है वही टेस्टिंग में अपीयर हो जाएंगे. जो ट्रेनिंग में है, समथिंग विच इज प्रेजेंट इन ट्रेनिंग, दैट विल अपीयर इन टेस्टिंग. तो मॉडल को मैं ट्रेनिंग से तो ट्रेन कर दूंगा, और जब मैं मॉडल को टेस्ट करूंगा टेस्टिंग से, तो मॉडल हाई स्कोर बताएगा, हाई एक्यूरेसी बताएगा, हम खुश हो जाएंगे, विल बी हैप्पी कि हमारा मॉडल ने तो बहुत अच्छा स्कोर दिखाया ना. अरे भाई, दिखा क्यों रहा है वो? इसलिए तो दिखा रहा है क्योंकि जिससे तुमने ट्रेन करा वही डेटा तुमने एक्सपोज कर दिया, तो दिखाएगा. ये गलत है, दिस इज अ रॉन्ग वे. इसीलिए सबसे पहले स्प्लिट करो डेटा को, फिर बैलेंस करो, और इस बैलेंस से ट्रेन करो. यू आर गोइंग टू ट्रेन द मॉडल विद दिस, और टेस्टिंग के लिए फिर इसका यूज करो. ये आपको बताना है, ये नॉलेज आप कैरी फॉरवर्ड करेंगे, दैट हाउ हाउ दे आर. यू आर हैविंग द स्कॉलर्स, आई गेस ऑल द फैकल्टीज आर देयर, यू विल बी हैविंग द स्कॉलर्स. यू फॉलो ऑल दीज स्टेप्स, ये करते हैं आप. डजेंट मैटर कि ये हेल्थ केयर है या मेडिकल है या इमेजिंग है या अदर डेटा भी है. ओके, ये तो जनरल जनरल कॉन्सेप्ट आई एम डिलीवरिंग. ओके, गॉट इट. क्योंकि इस प्रॉब्लम को कहते हैं डेटा लीकेज. ये नहीं होना, एक्सपोज नहीं करना है डेटा को. ओके, तो इसलिए हमने पहले आई स्प्लिटेड द पहले करा, ट्रेन में करा, ट्रेनिंग वैलिडेशन में करा, और सिर्फ ट्रेनिंग को बैलेंस करा है, टेस्टिंग को नहीं करते बैलेंस, ट्रेनिंग को करा सर. एंड देन आई क्रिएटेड अ मॉडल फ्रॉम स्क्रैच. CNN मॉडल बना दिया मैंने स्क्रैच से. CNN मॉडल क्या करा, आई आई मेड अ कन्वोल्यूशन ब्लॉक. I made a convolution block with convolution layer, normalization layer, ReLU layer, and pooling layer. Okay, I am having a 3-channel image with 32 filters I am taking in the convolution. Then I added one more convolution block with 32 channel, 64 filter. Again same normalization, ReLU ये जो है ये activation function है, नॉन लीनियर इन नेचर है. ठीक है, टू आइडेंटिफाई नॉन लीनियर पैटर्न्स इन द डेटा. ठीक है, फिर अगेन आई मेड थर्ड कन्वोल्यूशन ब्लॉक. अच्छा, सेम है, सब लेयर सेम रख रहा हूं मैं. कन्वोल्यूशन, नॉर्मलाइजेशन, रेलू, पूलिंग, कन्वोल्यूशन, नॉर्मलाइजेशन, रेलू, पूलिंग, कन्वोल्यूशन, नॉर्मलाइजेशन, रेलू, पूलिंग. ये सब मेरी ये कस्टम लेयर्स है, सब सेम है. ठीक है, ओनली कन्फिग्रेशंस चेंज हो रहे हैं. कन्फिग्रेशंस, पहले 3 चैनल इमेज था, 32 फिल्टर था, फिर 32 चैनल इमेज हो गया, 64 फिल्टर हो गया, फिर 64 चैनल इमेज हो गया, 128 फिल्टर हो गया, देन 128 चैनल इमेज हो गया, 256 फिल्टर हो गया, यहां तक पहुंच गए. एंड वट एवर विद आउटपुट आई एम गेटिंग, वो ये होगा आउटपुट. कि अब मेरी इमेज 14 क्रॉस 14 14 की साइज की हो गई है, 256 चैनल की हो गई है, ये है. तो उसको उठा के मैंने दिया लीनियर लेयर में, और यहां से फिर मैंने लगाया ड्रॉप आउट लेयर, लीनियर लेयर, ये लगाइए ताकि ट्रेनिंग हो. ये न्यूरल नेटवर्क है ये. तो यहां तक फीचर एक्सट्रैक्शन है बाय ब्लॉक नंबर 1, ब्लॉक नंबर 2, ब्लॉक नंबर 3, ब्लॉक नंबर 4. 4 blocks I get for convolution for feature extraction, and then I am going to apply the neural network for training. ये लगाना है. ठीक है, तो ये मेरा स्क्रैच का मॉडल था, खुद से बनाया, बन गया मॉडल. मॉडल बनने के बाद अच्छा ये ऑगमेंटेशंस है ना, आपको लगाना पड़ेगा प्री प्रोसेसिंग में। resize the image, flip the image, convert it into tensor or high dimensional data and perform the normalization. This is what you need to do. ठीक है, these are the augmentations. ठीक है, हमने मॉडल को 10 ईपोस तक ट्रेन करा, 10 टाइम्स, 10 इटरेशंस आई ट्रेन द मॉडल। ऐसा कुछ प्लॉट आ रहा है मेरे को, एक्यूरेसी इंक्रीज हो रहा है, लॉस डिक्रीज हो रहा है, अच्छी बात है। So with 10 iterations, 10 epos, I got the scores मुझे मिला है 89% का एक्यूरेसी मिला मुझे फॉर क्लासिफिकेशन, फॉर मल्टी क्लासिफिकेशन 89% का एक्यूरेसी मिला। सर 89% का एक्यूरेसी तो सर ये तो ऐसे तो पेपर पब्लिश नहीं होगा सर, 89 पे तो नहीं होगा। आप 95 प्लस करो, 96, 97, 98 ऐसे करके जाओ आप। ओके ठीक है, देन आई यूज्ड, ये तो बनाया था तो अब इतना स्कोर आया है मुझे। ठीक है, रिपोर्ट्स ये आपके सामने है, प्लॉट आपके सामने है। देन आई यूज प्री ट्रेन मॉडल, ये यूज करो। और आई यूज्ड VGG 16, 19 इंसेप्शन, ये सब लगा दिया मैंने, अप्लाइड ऑल दीज मॉडल, सब लगा दिया। ठीक है, एंड ये देखिए लगाने का भी तरीका है। ये जो मॉडल है, ये मॉडल VGG 16, आप ये लाइन देखोगे ना, इसका क्लियर मतलब है कि we are downloading the weights of a pre-trained model VGG 16 which is trained on ImageNet dataset. Okay, this is what we are doing. ImageNet dataset trained model. Okay, that's what I'm downloading the weights, and then I'm going to put up a linear layer for training with 4096 neurons and number of classes are 4, क्योंकि 4 क्लास हैं, 4 का मल्टी क्लासिफिकेशन कर रहे हैं तो 4 क्लासेस हैं। इसके वेट उठा लूंगा और ये क्लासीफायर मैंने बनाया है। ठीक है, इसमें एक लीनियर लेयर है और इतने न्यूरॉन्स हैं उसमें, तो मैं उसको ट्रेनिंग करूंगा। तो VGG 16, 19 सबकी इमेज नेट वाला डेटा सेट उठाया, रेसनेट 18 मॉडल, इंसेप्शन मॉडल, एक्सेप्शन मॉडल, ओके, डेंस नेट मॉडल, मोबाइल नेट मॉडल, एफिशिएंट नेट मॉडल, ये सारा मॉडल्स उठा लिया जो प्री ट्रेंड, ऑलरेडी इमेजेस का नॉलेज है इनको, बस मुझे अपने डेटा से ट्रेनिंग मारनी है फॉर पर्टिकुलरली फॉर अ लीनियर लेयर, ये जो लेयर है इसकी, बस इसको ट्यूनिंग करना है मेरे को अपने डेटा से। ओके, गॉट इट। हाँ, कुछ रिक्वायरमेंट और होती है, जैसे कि ये जो VGG 16, 19 ये जो मॉडल्स हैं रेसनेट वगैरह, ये दे रिक्वायर द इमेज रेजोल्यूशंस कैन बी लाइक 224, 224, बट ये जो इंसेप्शन मॉडल है, एक्सेप्शन मॉडल है, इनका रिक्वायरमेंट 299 है रेजोल्यूशन। So 299 resolution is required for inception and the exception, else image का size 224, 224 चलेगा, not an issue, ये ध्यान रखना है। और इनकी डिमांड होती है, एक चीज और मैं आपको बता दूं, एक चीज और है, ये बड़ी इंपॉर्टेंट चीज है, ये भी बताता हूं आपको। भाई प्री ट्रेंड मॉडल्स जो हैं, प्री ट्रेंड मॉडल्स, उनकी एक्सपेक्टेशन ये है कि हमें कलर इमेज चाहिए, बिकॉज वो कलर इमेजेस पर ही ट्रेंड है। द प्री ट्रेंड मॉडल्स आर ट्रेंड ऑन कलर इमेजेस ओनली, वो जो इमेज नेट का डेटा है ना, वो कलर इमेजेस का है, ग्रे स्केल का नहीं है। और आपकी जो इमेज है ब्रेन ट्यूमर वाली, वो तो ग्रे स्केल वाली है, ग्रे स्केल वाली, और आप यूज कर रहे हो प्री ट्रेंड मॉडल, तो भाई वो बोलेगा मेरे को कलर इमेज दो, तो ही मैं ट्रेनिंग करूंगा। तो वी नीड टू कन्वर्ट ग्रे स्केल इमेज इनटू कलर इमेज, एंड दैट्स वेरी इजी। ग्रे स्केल इमेज में 1 चैनल है, कलर में 3 चैनल है, तो 1 चैनल को 3 चैनल में कन्वर्ट करने का आसान तरीका ये है, काइंडली 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 शेयर द सेम इंफॉर्मेशन ऑन ईच एंड एवरी चैनल। मतलब ये जो 1 चैनल की इंफॉर्मेशन है मैंने यहाँ भी डाल दी, यहाँ भी डाल दी और यहाँ भी डाल दी, 3 चैनल हो गया। लो हो गया 3 चैनल, अब दे दो प्री ट्रेन मॉडल को डेटा ट्रेनिंग करने के लिए, कोई इशू नहीं है। ठीक है, दैट्स व्हाट आई डिड, दैट्स व्हाट आई डिड। दे दिया डेटा ट्रेनिंग करने के लिए. ओके, एंड हियर आई एम यूजिंग 5 ईपोस फॉर ईच मॉडल. 5 टाइम्स इटरेट कर रहा हूँ मैं. आई एम यूजिंग 5 ईपोस फॉर ईच मॉडल फॉर ट्रेनिंग. ओके, तो पहला है VGG16 model with 5 epos. This is the confusion matrix. And here is the classification report. I reached to 96% accuracy on 5 epos only. Okay. This much is the score I got. तो पहले जब स्क्रैच से बनाया था तो 89, then I am getting 89% score, 89% accuracy. And now I am taking a pre-trained model. I reached to 96% accuracy on 5 epos only. एक बात और ध्यान से, ये प्रिसीशन है. प्रिसीशन, प्रिसीशन का मतलब ये होता है बाय विच एक्यूरेसी ए मॉडल इज प्रिडिक्टिंग अ पर्टिकुलर क्लास, यानी कि मॉडल गिलोमा को 97% की एक्यूरेसी कर रहा है. दैट्स व्हाट इट कैन डू. दैट्स व्हाट गिलोमा कैन डू विद दिस मच एक्यूरेसी. मेनिनगियोमा को 99% की एक्यूरेसी से डिटेक्ट कर रहा है, नो ट्यूमर को 97 एंड पिट्यूटरी को 92. हमारी एक एक्सपेक्टेशन और होती है, ये बैलेंस होना चाहिए, है ना. प्रिसीशन भी मतलब बैलेंस होना चाहिए मल्टी क्लासिफिकेशन में. इफ यू आर डीलिंग विद दिस थिंग तो आप थोड़ा सा ध्यान रखिएगा अपने स्टूडेंट्स है जो भी हैं, ठीक है. ये बैलेंसिंग होना चाहिए प्रिसीशन के अंदर. सो विद VGG16 आई गॉट 96. विद VGG19 with 5 epos, this is a confusion matrix, this is a classification report, और मैं 97 पर आ गया. 1% का इंक्रीज, आई रीच टू 97%. ओके, बढ़िया है. 1% बढ़ा दिया, मॉडल चेंज करा. ओके, then I used Inception V3 with the same number of 5 epos. This is the confusion matrix, this is the classification report. 96 में पहुंच पाया हूं. सेम है VGG16 का. ये चेंज हुआ है, रिजल्ट्स तो वही आया ओवरऑल, अभी देख लेंगे. 96 है ऑन ऑन एन एवरेज. लेकिन ये देखिए, नो ट्यूमर को उसने 100% पकड़ लिया, लेकिन मेनिनगियोमा के साथ थोड़ी सी इसको प्रॉब्लम आ रही है. ये 91% ही है मेनिनगियोमा. नो ट्यूमर से 100%, मतलब सारा नो ट्यूमर इमेजेस इट कैन कैप्चर. मेनिनगियोमा को ये थोड़ा सा कम समझ पा रहा है. ओके, एनीवेज, तो हमें सिर्फ ये नहीं देखना है ये आ गया ना, खत्म बात नहीं है. ये अब देखो जरा, समझो कि बैलेंसिंग भी है कि नहीं है क्लासेस में. देन आई यूज एक्सेप्शन मॉडल, एंड एक्सेप्शन मॉडल I got 98%. Now this,
Excuse me, sir.
yeah, please say.
The screen is not visible.
The screen is not visible.
I mean, your slides. Yes, your slides are not visible.
I've
Sir, it
already
is
shared.
visible. I think the participant should check at their end because it is visible.
So it's a black screen, and in that your name is visible. Just
Okay, blank screen.
No, no.
I was teaching about this. I already shared.
No, sir, your screen was visible.
I'm.
okay. Let me
Let
check.
me share it again. I
You
think I
check
did
in
the
your
entire
end,
screen.
madam.
I think I did
Different.
the entire screen. Is it my screen visible? Can you see the code which I'm showing you?
So
Yes,
yes,
sir.
now.
Previously,
Yes, sir.
whatever I taught
It
on
is visible.
whatever I taught, those.
So just yes. Actually, just before 4 minutes ago, it has been closed. So I thought it may be you closed,
Okay.
but when you have described, so I just requested to that screen is not visible.
Okay, so this code from the
Okay, thanks.
starting, this code from the starting I shown is ये visible था?
Actually, I guess,
Yes,
sir,
sir.
the
Yes, sir.
screen
Yes,
was
sir. Yes,
already
sir.
visible to all the other participants. Some
Yes, sir.
glitch was there, Nisha, I guess, from your end.
Yes, it may be, ma'am.
Okay,
Yeah.
हो सकता है, ठीक है. तो इफ एनी इशू तो आप मुझे पिंग कर सकते हैं. अच्छा, वो आपने पिंग करा. ओके, सो आई होप नाउ इट्स
Thanks.
विजिबल टू ऑल. ठीक है, तो ये मैं रिजल्ट शो कर रहा
Yes,
था
sir.
आपको. फाइन. एंड रीच टिल एक्सेप्शन, आई गेस हियर इज द एक्सेप्शन. एक्सेप्शन का जो रिजल्ट है दैट केम टू बी 98%. तो मैं 96, 97, 98 पर पहुंच गया. नाउ आई एम इन अ बेटर पोजीशन विद दिस मॉडल ऑन ब्रेन ट्यूमर डेटा सेट, ब्रिस्क 1. with 5 epochs only. तो मेरा जो classification report and the confusion matrix which is coming, that is better than the other models. ठीक है, अब देख लीजिए 97, 98, 100%, 90, तो बैलेंस प्रिसीशन आ रहा है मुझे यहाँ पे। ओके, तो ये मेरा मॉडल अच्छा मॉडल है। दिस वन एक्सेप्शन। Meanwhile, I use ResNet also, ResNet 18. With ResNet 18, with 5 EPOS, 98% again here, मुझे यहाँ पर भी अच्छा रिजल्ट मिला है ResNet 18 आर्किटेक्चर पर। ओके, और प्रिसीशन स्कोर भी ठीक है, कोई इशू नहीं है, ओवरऑल एक्यूरेसी भी अच्छा है। फाइन, सो देखते हैं क्या करना है आगे। देन आई यूज डेंसनेट आर्किटेक्चर, डेंसनेट 1 to 1। डेंसनेट 1 to 1 से आई एम गेटिंग 98। ओके, यहाँ से भी 98 आ गया। एंड आई टोल्ड दैट कि ये जो आर्किटेक्चर्स हैं, मतलब मेरे फेवरेट में आते हैं, एक तो डेंसनेट है, ओके, इंसेप्शन इज ऑल्सो वन ऑफ माई फेवरेट आर्किटेक्चर, VG16 इज ऑल्सो वन ऑफ माई फेवरेट आर्किटेक्चर। ठीक है, इन्होंने कभी निराश नहीं किया, इन्होंने जो रिजल्ट्स दिए हैं हमेशा मतलब देखा गया अच्छा ही दिया है रिजल्ट्स। ठीक है, तो हम 96 98 पर अभी चल रहे हैं, स्कोर ऑफ 5 ईपोस चलाया मैंने। इफ आई रीच टू 10 ईपोस तो शायद बढ़ जाए, लेकिन एक चीज़ का और ध्यान देना है सर, ओवर फिटिंग ना हो जाए। अच्छा, ये भी ध्यान रखना, आप बताइएगा। ठीक है, कभी भी ओवर फिटिंग का मैटर रहता है, मशीन लर्निंग डीप लर्निंग, यहाँ पर ओवर फिटिंग। इन केस इफ इट हैपन्स कि ट्रेनिंग का एक्यूरेसी आ रहा है 98 और टेस्टिंग का एक्यूरेसी आ रहा है 90, तो यह मॉडल ओवर फिटिंग पे जा रहा है। ठीक है, ये आप ध्यान रखिएगा। जो गैप है ट्रेनिंग का एक्यूरेसी और टेस्टिंग का एक्यूरेसी, ये 3 तक तो चल सकता है, 4 तक भी चला लो मैक्स, 3 to 4% का गैप चला लो। अब ज़्यादा बढ़ रहा है तो फिर वो मॉडल ओवर फिटेड है। तो ओके, और ओवर फिटिंग को रिमूव करने के लिए फिर क्या करना चाहिए सर? रिमूव करने के लिए आप एक काम करिए, ड्रॉप आउट लेयर लगाइए, ड्रॉप आउट लेयर का इंट्रोडक्शन करिए। ठीक है, ये आपको हेल्प करेगा। बैच नॉर्मलाइजेशन है ही, ओके, रेगुलराइजेशन टेक्निक, रेगुलराइजेशन टेक्निक्स, इनका यूज करना पड़ेगा। तो ड्रॉप आउट प्रिफर्ड है यदि ओवर फिटिंग हो रही है तो। Okay, dropout means how many fraction of neurons you are going to drop while training. This is what a dropout do. तो ये रेगुलराइजेशन की एक टेक्निक है जो हम लगाते हैं। तभी हमने कहा ये बैच नॉर्मलाइजेशन जो लगा हुआ है ना, ये लेयर, ये डेटा को ऑर्गेनाइज करती है, स्केल करती है, ताकि इस तरीके की प्रॉब्लम्स ना हो। ओके, और हो रही हैं, यदि ओवरफिटिंग आ रहा है तो ड्रॉप आउट का यूज करिए आप। ओके, फाइन। एनीवेज, अभी तो ठीक है, ये टेस्टिंग स्कोर्स ही हैं मेरे पास 98। एंड देन व्हेन आई यूज मोबाइल नेट V2, आई गॉट 97 विद मोबाइल नेट, एंड आई गॉट एफिशिएंट नेट B0, आई गॉट द स्कोर्स एज 98। ये मुझे मिल गए। सो 96 to 98 मुझे रिजल्ट्स मिले हैं। और फिर जब मैंने उसको कंपैरेटिव प्लॉट बनाया, क्योंकि सारा मैं अपने रिसर्च पेपर में डालूंगा, ये प्लॉट डालूंगा रिसर्च पेपर में, कंफ्यूजन मैट्रिक्स भी मुझे डालना है अपने रिसर्च पेपर में, ऑल दिस थिंग्स आई नीड टू पुट। ठीक है, तो ये मेरा कंपैरेटिव है। बोलता है ना, गाइड बोल देगा ये आप एक काम करिए, ये कंपैरेटिव लगाइए आप अपने पेपर में, हमें देखना है। कंपैरेटिव टेबल भी लगाइए आप अपने पेपर में, दिस इज व्हाट आल्सो वी वांट टू सी। ये भी देखना है हमें, किसका कितना प्रिसीशन, किसका कितना रिकॉल आ रहा है। ये करो, ये प्लॉट लगाओ पूरा, तो ये प्लॉट है आपके सामने, और यहाँ से क्लियर हो रहा है 98.10, दैट इज एक्सेप्शन, ये जीत गया है। रेस्ट एफिशिएंट नेट 98 था, रेस्ट नेट 97.90 था, राउंड ऑफ करके 98 हो गया। सिमिलरली डेंस नेट राउंड ऑफ हो गया, मोबाइल नेट राउंड ऑफ हो गया। VGG 19 क्योंकि 97.40 था तो ये राउंड ऑफ नहीं हुआ। ओके, तो 97 रहा, एंड 96 एंड 96 ऐसा रहा। So winner is exception with this 98.10 accuracy with 5 EPOs इन सभी में। इट्स नॉट ओवर येट। मैंने फिर सोचा एक काम करो भाई, ट्रांसफॉर्मर भी तो लगाओ, ये तो CNN बेस्ड थे। देन आई अप्लाइड ट्रांसफॉर्मर ऑल्सो, विजन ट्रांसफॉर्मर। तो विजन ट्रांसफॉर्मर में ये रहा विजन ट्रांसफॉर्मर VIT B16 वेट्स इमेज नेट। दिस इज बेस मॉडल ऑफ विजन ट्रांसफॉर्मर। ये डाउनलोड करें, ये भी इमेज नेट पर ट्रेंड है, प्री ट्रेंड मॉडल है। ओके, गॉट इट। सो यू कैन डाउनलोड दिस मॉडल, यू कैन देन अगेन सेम थिंग, पूरा बाकी स्ट्रक्चर वैसा ही है, मॉडल चेंज करा है, मॉडल ऑफ विजन ट्रांसफॉर्मर ले लिया। ओके, एंड देन I trained the data with this model. Again, I'm just picking up the 5 EPOs only, 5 times iterate करा है। ये मेरे स्कोर्स आए हैं, ये एक्यूरेसी लॉस। अब यहाँ देखोगे, इससे पता चल जाता है, प्लॉट से पता चल जाएगा। ये देखो गैप है, जब ब्लू लाइन जो है मेरी, ये ट्रेनिंग की एक्यूरेसी है, और ये ऑरेंज वाली है वैलिडेशन की एक्यूरेसी, और ये गैप दिख रहा है। जितना ज़्यादा गैप है ना, हमारी एक्सपेक्टेशन तो ये रहती है। कैसी एक्सपेक्टेशन रहती है? ये रहती है, सर यदि ऐसा प्लॉट आ जाए ट्रेनिंग का और ऐसा प्लॉट आ जाए वैलिडेशन का, हमारी एक्सपेक्टेशन रहती है कि ट्रेनिंग की एक्यूरेसी वैलिडेशन से कम, मतलब वैलिडेशन वाला एक्यूरेसी ज़्यादा हो, और ट्रेनिंग का लॉस, ट्रेनिंग का लॉस वैलिडेशन से ज़्यादा हो। ठीक है, वी ऑलवेज एक्सपेक्ट वैलिडेशन एक्यूरेसी शुड बी हायर देन ट्रेनिंग एंड वैलिडेशन लॉस शुड बी लेस देन ट्रेनिंग, ऐसा होता है। लेकिन इतनी स्मूथनेस मिलती कहाँ है? वो जाएगा, ऐसा जाएगा, ऐसा जाएगा, ऐसा जाएगा, कुछ ऐसा जाएगा, आपको परेशान करेगा। तो ये सब खेल तभी होते हैं जब आपने डेटा को यदि प्री प्रोसेसिंग प्रॉपर करी ना, तो आप बच जाओगे डेटा की। तभी मैंने बोला था प्री प्रोसेसिंग अच्छी हुई तो मॉडल विल बिहेव बेटर, एल्स स्ट्रगलिंग होती है। ठीक है, एनीवेज अभी हमने विजन ट्रांसफॉर्मर लगाया, गैप दिख रहा है, मुझे लग रहा है कि यहाँ ओवरफिटिंग का चांसेस है, क्योंकि आप देखोगे कि वैलिडेशन लॉस इज मोर देन द ट्रेनिंग लॉस एंड वैलिडेशन एक्यूरेसी इज लेस देन ट्रेनिंग। ये ऐसे रीड करते हैं प्लॉट को, समझ गए? ओवरफिटिंग हो रही, देख के बता रहे हैं। ठीक है, क्लियर हो रहा है बात? खैर कोई बात, कोई भी नहीं, ये कंफ्यूजन मैट्रिक्स है, ये क्लासिफिकेशन रिपोर्ट है। एनी हाउ आई रीच टू 97 with 5 EPOs on vision transformer, and this is what I going to end the session. Madam, it's up to you. Yeah, anything you want to say? Anything? Stop share. Any doubts? Anything? I'm done with my side. Yes, I'm done from my side. Any questions? Any queries? Do you have? Madhvi ma'am?
The
Huh.
uh,
Nishta ma'am?
I request the participants to ask the questions if any.
Yes, any questions? Any queries? Any suggestions? And how you like the session? Nishta?
Okay,
Nishta
sir.
madam? Yeah.
Yeah, I mean, I would like to say thanks to you, sir. The session was truly very insightful and informative. Thank you, sir. Uh, on behalf of Amity University, Madhya Pradesh, I extend our sincere thanks to you for sharing your valuable time and expertise with us, sir. Dear participants, we will reconnect tomorrow using the same link at 2:30 p.m. sharp.